Let's say this is again the formulation of the modified query following Rocchio'a. Let's say this is the original query. That is the vocabulary, the size of the vocabulary is 7 terms, turn 1 up to turn 7. Sorry, 6. Sorry. Turn 1, turn 2, turn 3, turn 4, turn 5, turn 6. So the query is basically some combination of turn 2 and turn 4. Can someone guess what can be a possible query? What can be the QO? QO can be T2, T4, T4, 2 T4. That's why its weight is 8. 1 T2. That's why its weight is 4. So basically double. Okay. It's just a very lame way of interpreting this weight. Now let's say, based on this original query, we have performed an initial retrieval, and the user have marked some of the documents as relevant and some of the documents as non-relevant. That is, the user have initialized DR and DN1. And based on this two, let's say this vector looks like this positive feedback vector, and this vector looks like this negative feedback vector. So in the positive feedback vector, you can see turn 1, turn 2, turn 3, and turn 6 are given some positive weights. In the negative vector, turn 3, 1, 3, 4, and 6 are given some positive weights. This is negative. This is not negative, actually this is 0. So remember how we will be computing, again just repeating, how we will be computing this centroid. Basically we will be just summing their individual components up and we will be just averaging them with the number of relevant number of non-relevant document or the number of relevant document in the judged set. Okay. Now this can never be negative. Now let's say we are setting, so here there are 3 parameters as we have discussed, alpha, beta and gamma. Let's say we have set alpha to 1, beta to 0.5 and gamma to 0.25. So applying 1 into the original vector will be ending up with the same query. So this will be basically the same as original query, as we are considering alpha equals to 1. So here is basically QO is equals to alpha into QO, the original query vector, because alpha is 1. Now as we are considering a half belief on this relevance set or relevance non-relevant set, the individual weights will be half. So 2 will be 1, 4 will be 2, 8 will be 4, and 0, 0, and this will be 1. So this is basically based on the DR. Similarly, this will be for DNR. Here the weight is basically 1 by 4, not fourth. So here for the first term the weight was 8. As we are applying a belief of 1/4, so it has been reduced to 2. 0 is remaining 0 for turn 2. For turn 3 it was 4, so 1/4 it is 1, it is becoming 1. For turn 4 it is again 1. For turn 5 it is 0. For turn 6 it was 16, and after applying a belief of 1/4 it is becoming 4. Now if we apply this operation, what we will be doing is we will be basically performing this component wise addition. So basically this will be plus and this will be minus. isn't it? So resultant, what we'll be getting is 0 plus 1, 1 minus 2. But we'll be basically getting is minus 1. 4 plus 2, 6 minus 0. 6. 0, 4 minus 1. So 3. For the fourth term, it is 8 minus 1. 7. 0, 0, 0, 0. 0, 1 minus 4. So minus 3. So if we consider the individual weights here for the individual terms, they are basically this. This is the new query associated with term 1, term 2, term 3, term 4, 5 and 6. Now, wait a minute. What we are having here? What are these? So here, all these are vectors, right? In the vector space, all the documents are represented as vectors. So here the query is also represented as a vector. Now, in the vector, the dimension is considered as the number of terms in the vocabulary, isn't it? Now here, we are saying, we are observing that for some of the terms, the weights are basically set to a negative value. Now in vector space, as we have discussed, as we have pointed out here, negative weight is actually doesn't make any sense in this vector space model. So here, this actually doesn't make any sense. So what we'll be doing is basically making their weights as 0. That's what is stated here. And set negative term weight to 0. So even though the actually formulated query modified query vector, the vector would look like this with 6 components, but practically what we'll be considering is 0, 6, 3, then 7, then 0. Now, if we consider the new query or the modified query, this is basically the QM, and this is basically the QO. We can see the term was basically T2 and T4. Here, together with T2 and T4, we are adding a new term in the query, which is T3. This is a new term. Earlier, the weight of that term in the original query was 0. Here, the weight has been increased to 3. In the original query, the weight for T2 and T4 was 4 and 8. In the modified query, it is 6 and 7. How they are actually getting this weight is basically based on these two vectors and these 3 weights. So again, we started with the original query as some number of T2 and T4. I don't know how many. I have stated that T4 should be twice as many times it will be presenting as T2, but still it can be some other mechanism as well. So basically the Q0, the original query, QO, not Q0, QO will be containing 2 terms, T2 and T4, maybe with different weights, 4 and 8. The modified query, what we have is basically T2, T4 together with that T3. This will be the modified query. So what we are doing is we are adding this term into the query. More formally, we are expanding the original query with this additional term. This is also called expanded query. Any question up to this? This is a very important topic. Anyone having any doubt, any question on this? All right. Now again, let's consider this again, this formula. Consider this NR. What should be regarded as NR? So if we consider, as we were saying in the sometimes back, with a very lame example, shall we be considering only the documents marked as non-relevant by the user as NR? The answer is no. Why? Because as we have said, there can be multiple different type of other non-relevant document present in the collection as well. So this is basically too little information. Shall we consider all the documents, all the basically not relevant document as non-relevant document? This should also not be considered, because as we have said in this example, if we have only 100 non-relevant document, but if there are more than that number of relevant documents there for the query, here in this case 200, if we consider all the documents which are not marked as relevant, as non-relevant, then 100 of this actual relevant document will also be considered as non-relevant document. Isn't it? I'm again repeating. So let's say the collection is containing 10,000 documents. Out of them, we have marked 100 as rel, 100 as non-rel. But actually there were 200 rel docs. Now, if we consider all the document except this 100 rel document as non-relevant document, then we are basically considering 9,900 document as non-rel. But actually, the number of non-rel document is now 9,800. So actually 100 rel documents are being considered here in this count, which will be basically keeping this centroid, moving the centroid, not actually away from the relevant non-relevant set, because as there are some relevant documents involving this DNR, it will be basically it will be just a jumble of many points, many different topical points. So that's why all the unseen relevant documents should also not be considered as non-relevant set of non-relevant documents. So there should be a trade-off. Again, as I have said earlier, the weight, how many documents you are, irrespective of how many documents you are considering in NR, the weight gamma should be set to a very less value. So the next question is, how should the terms be selected, and how many new terms will be selected? As we have seen in this example, we are considering for this small 6-term vocabulary, we are adding one term, right? So if the vocabulary size is say 10 million, let's say 1 million, there will be multiple. So basically there will be, this vector will be of size 1 million. So there will be multiple places for which we will be getting a non-zero value, non-zero positive value in the places where it was earlier a zero value in the original query. So how many of those non-zero terms, non-zero positive terms should be considered as the expansion term? Basically, we can actually rank those terms based on the number of relevant documents, non-relevant documents they are occurring in. Also, they can also be ranked based on the set weight. Here the set weight is 3. For some other terms, say TI, if we see the weight is say 5 for another term, say tj, let's see the weight is say 8. So the new expansion term weights are basically 3, 5 and 8. We can actually sort them and consider the highest one, or say highest 10 or highest 20 terms having higher weight as the potential expansion term. And finally, practically we have seen that around, adding 50 to 100 terms, new terms in this existing, together with this original query will be resulting in a better retrieval.